So this is a community meetup, community call. So this call will be pretty relaxed, and we'll have two people on this call. So first is me. I'm Sida Shen. I am a StarRocks contributor, and more importantly, we have Harrison here. Harrison Zhao is a StarRocks TSC member, technical steering committee, and Heng is Harrison is really knowledgeable in terms of analytics, infrastructure, big data, especially StarRocks. He's been with this project since the very beginning, 4 or 5 years ago. So say hi to everyone, maybe Harrison.
Hi everyone. I'm Harrison, and I work for StarRocks open source community for a long time, just from the beginning. And we open source this project nearly 3 years. I think maybe in September this year we got the 3-year ceremony, and very glad to hear the voice from the community, and also I run some roadmap in GitHub issue, and very glad to hear some suggestion. And
Yeah, beautiful. Harrison is really knowledgeable in terms of StarRocks, and he's probably one of the most knowledgeable person in the world in terms of like knowing StarRocks. So if you have any question, please submit them in the chat or in Q&A, either way, right? And we will address those questions in the end. Okay, so now let's get started. That's enough chit chat. And so first, let's go over the agenda. I looked over the sign up sheet, and I did spot some new people, new users. So we'll first give a quick intro of the StarRocks project and its deployments and its use cases, right, and what it can do. And then Harris is gonna take the stage and introduce 3.3.x new features. So small releases, 3.3.1, 0.2.3, those new features. And then he will talk about some of the exciting projects that we're working on now, right? Some exciting new PRs, including ANN vector search. So definitely stay tuned for that. I'm looking forward to that as well myself. And then I will talk about some StarRocks community news, right? Some new exciting case studies that's been happening in the community and new articles, right? And then we will talk about some commonly asked questions I found in our Slack channel and also talking to users, right? So hopefully get those answered, and hopefully it can be helpful for you. And then it's a Q&A session. So hopefully you guys can ask your questions, and now we're gonna get them answered, right? So first, StarRocks. So StarRocks is really good at doing data warehouse-like workloads. So there are like mainly two use cases for StarRocks. So first is as a query engine for a data lake or data lakehouse architecture, right? StarRocks has native support for popular tables and table and file formats, open table and file formats, table formats such as Delta Lake, Apache Iceberg, Apache Hudi, and Pyman, right? And also popular file formats such as Parquet files and ORC files, right? It's a newer generation of query engine that's really designed to give you the best possible performance for your data lakehouse, right? It's written. It has an MPB architecture. It can do in-memory data shuffling, and is written in C++. So it's all SIMD optimized to handle your complex OLAP queries, right? Also has a caching framework that's built for cloud storage, like AWS S3, right? Directly query storage, S3 storage, and cache the data for better performance, right? So ultimately, you can get data warehouse like performance with StarRocks on the data lakehouse, right? And the second use case is really for real-time analytics, and this is where StarRocks' own storage engine comes in, right? Despite StarRocks can query external storage systems such as Apache Iceberg, Hudi, and Hive. StarRocks also has its own storage engine that is able to give you really fresh data, right? real-time mutable data directly on StarRocks columnar storage, right? Sub 10-second data freshness with data upserts, right? And also give you sub-second queries at scale, absolutely best-in-class performance in terms of real-time data warehouse kind of alternatives, right? And also it can do joins on the fly. So there is no denormalization pipelines required, if you want to do real-time analytics or customer-facing analytics, right? So you don't need to have your stateful stream processing jobs running, right? Instead, you can do joins on the fly, right? Also, it has a compute storage separated architecture. We call it a shared data architecture, which means that when you're ingesting data into StarRocks is able to persist the files in external storage, such as a cloud object storage like it was S3, and directly query the files that are stored in a remote storage, right? Also has a caching framework that the same caching framework, the Lakehouse solution, right, to accelerate your queries so you don't, so you get the best possible performance. Okay, so now I will hand over the stage to Harrison, and he's going to talk about 3.3.x releases and some of the exciting projects that we're working on in the community, right? So can we get Heng, Harrison on the stage?
Yeah, and thanks to that opening, and I will cover the second part about the StarRocks 331 and 332, these two release. Actually, version 3.3 is a relatively important release, and we may maintain it for longer than previous version. And Sida has already provided a comprehensive overview last month and for version 3.3, and we have some minor feature and improvement in these two versions, and also we want to make this version 3.3 more stable in next few months. So maybe we will merge some feature in before 3.5, I think. And in August and September, we still have some feature, a new feature and improvement. But after that, we will just do the bug fixes. So I want to address these two versions today, and to give a general introduction to some features we released in past 2 months. And the first part, I think, I split it in maybe 4 parts. And the first part is about StarRocks internal table related. And we introduced, the first is a usability feature. We introduced a rename column. And actually, it's a pain point for many customers. StarRocks can do it before. It is very useful in some scenario, particularly for when you do some data modeling and you want to make the column name readable, and with some data governance standards, you need to change the data column name. You can do just the auto table to rename column to another new one, and it is supported for all kinds of column, including some indexed column and some sort key. All the column is supported in this, but still some a little limitation you may care about, that after renaming column from A to B, and you cannot add a new column named A, and this restriction maybe you need to consider when you're planning to do such kind of schema changes. And the second feature I want to talk about is optimized table online. And we can do StarRocks. There is a very important concept is a bucket and the distribution policy. It is important for some performance tuning, and in previous version we introduced a lot of feature to make it easy to handle. Maybe you needn't to care about the bucket number. We can do automatically bucket number detection, and even in 3.2, and you can do automatically tablet creation. When you ingest new data, we will create, but it's only for random policy, random distribution policy. So it's always have some bad case. Not always. It still have some bad cases, and it's hard or maybe impossible to find the best bucket number and the bucket size for all the cases. So we have to do some alter table to change the previous bucket number or bucket key, and maybe some newbie just write a table in order to get the easy to use. Maybe they don't care about that, but when the data increase every day and the data always changes, so we need a method to change that, which we call it optimized table. And in this version, but in previous version, optimized table maybe conflict with some DML operations such as data ingestion, especially for primary key table. You need real time to update the table, and the optimized table may be easy to need to rewrite all the partition or all the table, so it's easy to conflict to fail. So we optimize this feature and make it can running simultaneously, so it's easy for real-time ingest scenario to do the online optimized. And the third part is temporary tables, and it's most used in ETL jobs, and you may create a lot of temporary table to do complex ETL, and it's also a session. You need to do some session level data isolation. For example, the temporary table is bind with your session. When the session is end, and it will automatically recycle the table, and you can do several concurrent ETL jobs with the same temporary table name, and they won't come. They will be isolated from each other, and you can run it without conflict. And the last point about the temporary table, it can use to optimize some performance. For example, for some subquery or a CTE, yeah, and you needed to build one temporary table and you use it everywhere. And actually, in our planner, we can do some automatically query rewrite to change the subquery or CTE to temporary table to get better performance, and you needn't to care about that. Yeah, it's a. And yeah, last you can check the document. Yeah, we can create a temporary table as select or like or basic. Yeah, it can support all kind of grammar. Yeah, and the next part is about semi-structure improvement. It's very important for StarRocks to cover all kinds of struct, map, JSON, and the one of the best performance is struct, actually, because it's have the best performance. We can directly query to the exact field, and we introduce a new feature. You can add and remove field in struct. For example, you can add a field after some field, or you can add a field at the beginning of the position, just use the keyword first. And also you can add field into a nested structure, such as array struct. Yeah, you can check here. Yeah, here's use a star to imply the array. Yeah, the next feature is a user-defined variables, and it's usually used with other functions such as temporary table. And I saw that there are several feature requests to ask for store procedure in our Slack channel and GitHub, and I think you can use the user-defined variable and the temporary table. And furthermore, maybe we can improve, we can introduce multi-statement transaction, and they can also achieve some kind of store procedure. Maybe not the compatible with PG PG SQL, but we can also achieve such kind of capabilities. And we introduce array type in 332, and you can use like this and you can set and select from that. And last is a array function. Okay, and the next topic is about some data ingestion improvement. The first is we can support data compression for stream load, and this is used some scenario for cross-cloud or cross-region data ingestion. Maybe the traffic fee is not is very high for such kind of scenario. And here is feedback from community. Yeah, they got when they enable LZ4, and they just spend a very little CPU usage and can achieve about 17 to 19% reduced from the traffic. Yeah, and the next part is about a partial update. In yeah, we can support partial update in column mode is significant. Enhanced the performance for partial update because it just it needn't to read all the row. When you have a large flat table and a wide table and update one or several columns is very important. And there's several scenarios. The first way be you can, when you're using generated column and to do some generate a new metric, for example, and you need to update this metric when and to do some when some new data ingestion, and you can do such kind of thing. And or other, you maybe some feature engineering. You have very wide table. They are each, maybe you have some several column family, from column 1 to column 10 generated by a machine learning job, and maybe you can use Spark to partial update such kind of columns. And yeah, and that's just enable the column mode. You can get the best performance. And we support this in shell data architecture in the recent release. Okay, the last part is we can do some data automatically to do some data converting JSON type data into the struct map array when you do ingestion, which means you still can do some ETL before the data loading. In the loading process, you can do such kind of transformation. Yeah, the last part is some feature about data lake and the ecosystem. And we can direct a query to iceberg in 332, and you can create, replace, drop the view, and also show create the view for iceberg tables. And yeah, it's very reasonable to use view to do the logic modeling instead of denomize all the things. And also it can provide better interoperability for different engine on iceberg. For example, you have Spark or Trino to do create some iceberg view. Yeah, but yeah, we have some limited capability to query direct to Trino or Spark views, because we have a Trino dialog. If we can support the SQL, maybe we can convert the Trino SQL to StarRocks internal AST, and we can support that kind of view. And yeah, so it still have some limitation, and we're still working on that. If we can get all better capability for Trino dialog, and we can achieve all better interoperability for all the query engines. And the next part is it seems a small minor optimization for data cache. But it's very useful for data cache observability. And we offer 2 new interface to check the cache hit rate for queries. Yeah, the first one is app static, which you can achieve the hit rate, and which calculates as the remote read bytes divide the remote read bytes plus the data cache read bytes. And it's maybe a North Star metric for whether, because we in StarRocks provide a lot of cache mechanism. You can use the cache select to do some warm up, and also we have some cache mechanism. For example, in StarRocks share data table, and you can set the partition, which partition should cache in the local disk and which shouldn't, and use different mechanism. We still need a final metric to define the policy is good or not, and to do some minor adjustment. And the last state, this may be used for some debug. It can show some detail and to find the bottleneck and identification for data cache. And we also introduced a JDBC catalog which can support Oracle and SQL Server, and we can provide the column level permission in Apache Ranger to get better fine graduated privilege management. Okay, here's just a quick think about the community, and next I can talk some work in progress projects and in these 2 months. And we have a lot of projects at the current stage. I just pick some interesting, maybe very few projects here. The first one, I think, is a vector index and ANS search, and it's very popular for some RAG system recently for working with LLM, and we already support the basic search functions for a long time, but we haven't have a vector index. And Tencent guys help work with us and to provide this brilliant feature. And I think it can be merged at the end of August, and we are launched in next version 3.4, I think. Yeah, and the second is a group commit. Group commit is used for some high concurrent data ingestion when maybe StarRocks can't cover. It's still StarRocks is still a micro batch system, and we can cover very high concurrency like TP system. But with this kind of group commit, we can merge the small transaction into a larger one, and it can cover more performance, more scenario. Is, for example, some IoT scenario. Yeah, and the third one is about the data sketch hyperlog log. StarRocks introduced hyperlog log for a long time, but the precision of the hyperlog log is not good enough, and we introduced a new data sketch library to get better precision, and also it can be tunable. And with this PR, and we also introduced a new kind of general aggregate states, and which can benefit to the materialized view in the future, maybe synchronized materialized view or asynchronized materialized view. They both of them need to store the intermediate query state or query result in materialized view, and it it will be possible to do some incremental materialized view refresh with the general aggregated states. Yeah. And the next part is of flat JSON. Flat JSON is introduced in 3.3, and we improve this recently. And first, we can support it in shell data architecture, and the second, we can support some nested JSON flatten. In the very beginning, in the first version, it's still a preview feature, and so we just support the one layer flatten, and in this in the next few version, and we can support the nested JSON flatten. And for iceberg, we still have some improvement and to support the iceberg branch and tag and time travel, and also for iceberg metadata table. So yeah, here's a basic working progress project, and I can show some results and some test result about this. And yeah, here is the basic prototype of the group commit. Yeah, for high concurrence scenario, we need to we can combine 3 stream load into one stream load, and you just need to specify the group interval MS, and we will StarRocks will automatically to merge all the stream load into one. And in the initial test, it showed that we can handle over 300 table with 3 concurrency for each table, and which means total 19 kilometer events per second. Yeah. And the next, yeah, I think yeah, we can talk about some vector index and approximate nearest neighbor search. And we have supported the cosine and equivalent distance and for high performance vector search, but it's a brute force and function. And we also integrate with LangChain long ago, and you can using StarRocks as a vector store in rack applications. And we're working on vector index recently, and we can support the H1SW and IVFPQ. These are the most important index, and they can cover different scenario. For example, IVFPQ will cost less memory, and H1SW maybe can offer better accuracy. Yeah. So, and you can also using some kind of hybrid search with we have full text search and vector search and some scalar filtering, and combine these together, we still have some options to expose. You can choose some pre filtering or post filtering. You can get the different performance or accuracy for the application. Yeah. And yeah, Tencent got some practice in this and got a very pretty good performance. Yeah, here is a very simple comparison with other database, with other vector database with the vector DB bench, and we can StarRocks can got the less the best query latency and also the highest QPS in all the test cases. Okay, yeah, I think that's all from my part. And yeah, you can ask some question and we can answer the Q&A at the latest part. I think I can hand it over to Sida.
Hello. Good to see you guys again, and thank you, Harrison, for the introduction to our new features and what we're working on. Really exciting stuff. And I do see a lot of questions in the Q&A and in chat. We're gonna handle them in the end. I'll just quickly run through what I have, and then we'll handle those questions. Harrison is here, so and he's really knowledgeable. So now is really your best chance to get your StarRocks related questions answered. So if you have any question, please in the Q&A session or in the chat, right? We will answer those questions in around like 10 minutes. Okay, so I'll quickly go through some exciting community updates. And so first is we have a new case study. Pinterest has just published a blog post about their usage of StarRocks on their partner insight kind of application, right? Customer insight scenario. So partner insight is kind of like a application for their content creators to log in and see all of the stats, see how they're doing, right? And once they switch to StarRocks, they reduce their P90 latency by 50% with only 32% of the instances that's required by the previous solution. And also data ingestion process also seen an improvement as well. So they were able to achieve a data freshness of just 10 seconds. So this is great, and please go over and check out their blog here and give it a like, right? And this is great. This is on the Pinterest medium. Our presentation is live. So around 2 months ago at the Databricks Summit, Data+AI Summit, myself and Erickson from Coinbase, we did a talk. We talked about how to get data warehouse-like performance on the data lakehouse, and also Eric provided a sneak peek into their data architecture, right? With StarRocks doing real-time analytics, with Unity Catalog, unifying all of the governance, right? And with a single source of true data lying in their data lake system, right? With StarRocks, with PuppyGraph, and with DuckDB, with multiple engines on one piece of data. And this is good. And the video is live here. So if you go to Databricks YouTube channel and find Data+AI Summit 2024 Lakehouse track, and on this list you can find the video, the 9th, or you just Google this name, data warehouse performance on the data lakehouse, right? You're gonna find this, and this, you can check this out as well. So this is a use case from Coinbase. And also we had many new community donated written articles, right? So these are on StarRocks.io blog, and we do have more on the StarRocks engineering medium blog post. So if you have some cool story with StarRocks, or you learn something that might also help other StarRocks users, you can submit your articles right now. You can schedule a 30-minute meeting with me. I can help you brainstorm. I can help you organize the article, right? Do some cleaning up. So if you're interested in doing an article, or even doing a video on our YouTube channel, please let me know, right? Happy to help. And then, so this is the last part. I'll go through this fast so we get to the Q&A session faster. So there are a lot of questions in our community Slack channel, and also I get a lot of messages, new users asking questions. So I took the most commonly asked questions and put them here. Hopefully this is helpful for you. So first one, what is the difference between BE and the CN? So they're similar, but on two different kind of architectures. So with StarRocks, you can deploy it two ways. So first is a shared nothing deployment. Second is a shared data deployment. With shared nothing, so everything is persisted. All of your data is persisted in your local storage, right? So BE backend, it does storage and query execution and data scanning, right? But with shared data, your data is persisted in a remote storage. So BE becomes CN, so it doesn't persist data anymore, right? It only scan the data, and then it does caching, and then it does query execution, right? So B and C are almost the same thing, but with two deployment methods, it does things a little differently, right? And second question, Lakehouse versus shared data. I see a lot of users asking me, is your shared data, your Lakehouse solution? The answer is actually no, right? A Lakehouse, I think the biggest difference between a Lakehouse and or not Lakehouse or a data warehouse solution is not where you persist the data. You can persist your data in your cloud object storage, but still you're a data warehouse, right? The key is the format that your data is stored in, right? With a Lakehouse or a lake solution, right, is open, is with a open table format like Delta Lake, Apache Iceberg, Apache Hudi, and with an open file format such as like Parquet files, with a open catalog service, that expose the metadata to a query engine, right? And this is like an open data lake architecture, and StarRocks can be the query engine that reads the open catalog and directly query the Parquet files that's managed by, let's say, an Apache Iceberg table, right? As a data warehouse, StarRocks stores its files in its own format, right? So not open formats, not standardized formats. So those two are absolutely different, right? And does data cache ensure correctness of your result, right? Let's go back and take a look at what caching does, right? StarRocks is able to directly query S3 files, files stored on your S3 storage, right? But we have a caching layer that cache the data and accelerate the queries, right? And the answer to this question is yes. Data cache can ensure correctness. So the thing is, query and cache, share the same metadata freshness. So let's say if you're on the open data lake, right? The metadata is synced from the external system, right? And periodically, right? So the freshness is actually controlled by the metadata cache. So like how old that metadata is, and this is actually configurable, right? The default is to 10 minutes. So how correct or how fresh your data is, it's actually configurable, with StarRocks. Next, so what are the two materialized views, right? We have, if you look at the documentation, we have a synchronous materialized view and we have an asynchronous materialized view. So what they do, how they're different, when should I use which? So first is the async materialized view, and this is the one that we're devoting most of our energy on, right? It works with data lakes, so you can create materialized views on your Apache Iceberg, Apache Hudi tables, and convert them into StarRocks format and do transformations, right? It supports full join queries, so you can create a materialized view with multiple tables. And also it supports incremental refresh, but only on the partition level, right? So if your data is partitioned, the materialized view refresh can be incremental, right? And support full query rewrite. Talk about this later, and it's mainly used, for query acceleration or data warehouse layering, those kind of scenario, or accelerating your data lake query performance, right? And the second one is synchronous materialized view, and this is almost just directly the opposite of the first one, right? And this does not work with data lake, and this doesn't have join support. It only work with aggregations. But the key is it support record level incremental refresh. So it's synchronous. So it's always up to date, right? So all of the refresh is incremental, so it's very cheap, right? So all of the refresh are resolved at data ingestion, right? And also supports full query rewrite. And this is mainly used for real-time pre-aggregation, right? You would use this when you want to preserve your detailed data, right? Let's say you have a fact table, right? You want to preserve that fact table, and also you want to roll up, do a roll up of some dimension, right? You will use this. And if you don't need the fact table, we actually have a aggregated table that doesn't, don't preserve that. You only preserve the aggregated result to save storage, right? And that's the aggregated table, aggregated key table. Okay, and is there any limitation to materialized views query rewrite? One of the key, and this is asynchronous materialized views query rewrite. Query rewrite is amazing, for materialized views. So you don't really need to change your SQL script in order to benefit from your materialized view, right? So it separates a role between your data engineers and your data users, right? So the data user doesn't really have to do anything, write one script, SQL script, and it's gonna work, even with materialized view that's added, right? But asynchronous materialized views query write does have some limitations, right? Only works with SPJG queries. So this part is kind of limited, right? But we do have it doesn't work with all of the SQL that's out there, right? But we do have a view-based rewrite that was introduced in 3.3, right? That's going to be a game changer for rewrite capabilities. So in terms of like how complex the query is, right, or how weird the query looks like, right? And we can still, do rewrite. So what this does is that if you create a view first, and then you build a materialized view on top of that view, it is going to work, right? So the rewrite is going to work from materialized view to the view, right? So the best practice right now is, if you are modeling your data, right? So you always want to encapsulate your logics into views, right? You build views first, and then you see, which one is slow, and you accelerate those views and turn them into materialized views, on demand, right? Yeah, and the query rewrite is going to work. There's only one small limitation, is that it works with all queries except for non-deterministic functions, which means that the result of a function is not deterministic, like current time, right? Because current time changes all the time, right? So view-based rewrite, definitely give this a try. It's a game changer for MV, right? And also, how do I control my materialized views consistency level, right? So there are two scenarios with this. So one is you create the base table and the rewrite, and the query reroute your query from your base table to your materialized view, right? And the other one is where you create the materialized view directly, right? If the data is too outdated, it rewrites back to the base table and grab the latest result, right? And to ensure consistency or correctness or data freshness, right? And with the first one, so with materialized view, with base table rewrite to materialized view, right? Query acceleration. There are different modes, right? You can pick to force a rewrite, or only rewrite when the data is correct, or there are many modes, and this is controlled by the materialized view rewrite mode parameter. And also you can there is another configuration, right? Materialized view rewrite staleness seconds. So this says, okay, so what kind of data freshness do we need, right? So the staleness tolerance for materialized view data during query rewrite, right? From your base table to the materialized view. And on the right, transparent MV rewrite mode. And this is for when you are querying your materialized view directly. And when does it rewrite to the base table to get the most up-to-date result to ensure correctness, right? And there are modes in this as well. You can look those three up in the documentation, right? And this is actually all I have. And can we look at some questions? Oh, there are a lot of questions. Okay, so one by one. Heng, Harrison, you ready? Okay, so the first question, I think I made this public. Does it work? Okay, if you go to the public questions, yeah. I'll read out the questions. At this time, StarRocks has some impressive ingestion capabilities, but it's falling short on streaming data export capabilities such as CDC. Any technical challenges that you see in adding such support for CDC?
Actually, we implement a prototype for that, but it's not production ready, and it's really challenging for StarRocks to implement a CDC to outsource. And first, you can consider it depends what kind of scenario do you want. And we introduce a cross-cluster migration tool, and we can sync StarRocks data into another StarRocks cluster incremental, and but it's still using our internal clone mechanism, so it's not for public. And yeah, for duplicate table, we implement a prototype, and we still consider about these things, and especially for Flink and also for StarRocks internal materialized view. Yeah, and maybe it still costs some. We're still working on that, actually. Yeah. And the next
next question. Sorry, I was looking at the questions. Is this change going to get rid of the too many versions problem? So can you?
Yeah, I think it's talk about the group commit, actually. Yeah, I think group commit can greatly mitigate the too many version issues, I think. Yeah, the most common case is that there are you have a lot of concurrency to do data ingestion, and that will cause too many infection. But also there may be other reason to cause too many versions. For example, the compaction, the I/O, the disk I/O. But I think it can group commit can mitigate most of the cases. Yeah.
Okay. Thank you, Harrison. And next question, with regards to converting JSON to column, very cool. Do the columns have to be defined beforehand, or it is a feature capability of destructing dynamic different JSON objects?
Yeah. I think it's a good question, and we can directly query to JSON, and but JSON is flexible, but not the performance version. And there are several ways to deal with. You want to improve the JSON performance. The first is you can create a generated column and just extract some data from the JSON. That will be, you can still query the JSON function, and we will do query write to accelerate that. This is the first one, but it's still to specify which column you should to accelerate. And the second, you can considering about the flat JSON. Flat JSON, we are in 3.3. Yeah, we introduced this, and it will automatically flatten all the JSON object, and to accelerate. But we still working on to improve that. For example, as we talk about it, we can flatten other the nested JSON 2 level or even 3 level to accelerate all the JSON, but it will cost some extra storage and maybe some burden for data ingestion. Yeah, that's you can trade off between which kind of mechanism do you choose. Yeah.
Thank you, Harrison, and thank you for the question. And next question, is the group commit prototype more applicable for general cloud storage and not real-time analytics? It sounds like it's a batching more, so it could impact read availability, right?
Okay, yeah, I think it's still a batching more. Yeah, that's right. It's a batching method, and it can it will be sacrifice some data freshness, but also can benefit from the high concurrency data ingestion. And it's still working for near real time. Maybe I think it's not that real time to second level, but you can control to minutes level. For example, you can set the group commit interval to 1 minute, and it will group commit all the data in near real time.
Okay, thank you. Will these slides be shared later? Yes, and this video will be available on YouTube. We'll send you an email. Next question. Is there any plans to support maintenance of external tables like iceberg compaction, snapshot expiration, etc.?
Yeah, that's actually we are working on, and we still we will provide a first a compaction interface just to compact iceberg table and recently. Yeah. And furthermore, we were considering about a compaction service. Actually, StarRocks have an internal compaction service. We just released a blog post to describe how StarRocks internal table to do the compaction and the mechanism, the tuning options, and we want to make it available on iceberg table. Yeah, that's a yeah. We receive a lot of requests like this, and I'm also interested in your scenario. Yeah, because yeah, iceberg is a very open ecosystem, and we still invest more on this topic. Yeah.
Yeah, this is really exciting. So if you're looking for iceberg compaction or those like Lakehouse or lake maintenance and how current solutions are bugging you, please let us know, and maybe we can do better.
Yeah.
Okay, so next question: if only CN without BE, does it have problem creating tables? I think I can take this one. So CN and BE are, how do I say it? Similar things, but in two deployment options. So CN would be your shared data deployment. So your worker nodes will be called CN because they only do compute and they do not persist any data on them. So it only caches data. And with BE is with the share nothing architecture, right? So BE actually persists data, and it also is a workhorse. It queries and it does query execution. So both, yes, they will be able to different deployment options. Anything to here, Harrison?
Yeah.
No? Okay, next question. So is it good to ingest Kafka streaming data directly into StarRocks or to do batch ingestion? I think this one is really up to like what you're looking for and what your scenario look like. So if you need fresh data and your data freshness, like you can ingest with smaller batches, right? With small intervals. So just keep your ingest intervals like around 10 seconds or more. It's going to be stable, right? But it depends on your scenario and your data size, data volume, right? But generally, if you want to do kind of like more real time, like 10 seconds is where it's going to be pretty safe, right? Anything to add here, Harrison?
No, that's good.
No? Okay. I can't really hear you. Sorry. Oh, sorry.
Okay. Next question, I think.
Oh, I think sorry. There's a problem with my speaker. I couldn't hear Harrison. Oh, now I can hear you.
Doesn't
sorry. No, it's my microphone. It's trying to send sound to my microphone, my computer. I don't know why. So okay. So what you was I interrupting you?
No, just go ahead.
Oh, okay. So next question. So on most of your slides with architecture, numbers of FE nodes equal to the number of BE nodes or number of CN nodes. Is this the best practice to plan installation like that? So no, it's just a coincidence. So FE, we do 3 FEs normally for high availability reasons, right? Because FE persists metadata, and we want to high HA, so we have 3 FEs. And B's and CNs is really how much like muscle you want in your cluster to handle like large scale queries and like really massive scale data ingestion, right? Mostly queries. And we do have a best practice article on StarRocks.io that helps you with provisioning resources, hardware resources, like how to do the calculation, and it's great there. But with FE, unless you have like just crazy amount of QPS, 3 is typically sufficient for a production system, right? But if you like high in the thousands of QPS, maybe more FEs to handle the query planning. But generally, FE, you don't need as many FEs as BEs. BE, you can scale that up to like hundreds. No problem. Okay. Does StarRocks support High 4.0? That I'm not sure. Harrison?
I think this question, I need to clarify this. And Hive is a Hive. Do you mean Spark for Hive?
Hive, does it have 4.0?
Actually, I think we haven't tested that before. Yeah, I think we can. So we need some more tests about that.
Okay, so let's do next question. We still have more. Where am I? Okay, is there a plan to support something like speculative execution in Apache Spark in order to detect slow tasks and relaunch them on different nodes to avoid potential hot spots during queries?
Yeah, actually, we working on for some data skill, and when you've met some data skill, we want to do some redistribution. We built such kind of mechanism recently. Maybe not the same as the specular execution, but the similar methodology and the similar thought about that. Yeah.
Okay, next one. Does colocation work in shared data mode?
Yeah, I think the two topics for shared data model, it supports the collocated table, and for iceberg table, it doesn't support collocated. But you can create a materialized view on top of the iceberg table, and you can make free use of StarRocks internal table capabilities such as collocated join. Yeah, collocated table.
Next question: is there a ORM support? I think this object relational mapping. Is that for StarRocks FE?
Yeah, you can use the SQL Acme based ORM is supported. Yeah, it's I think it's the most popular one, and we can support that. Yeah.
Okay, great. When will group commit be available? Which version? I think.
I think the next version 3.4. Yes, it's still a prototype, and we need more tests in next merger version. Yeah.
Do you guys plan to introduce any kind of training or workshops on specific topics or certifications?
Yeah, that's a good question. Yeah,
that's a good question. We should think about that. Yeah, but we do have like regular webinars. If you guys like what we're doing now, we're probably gonna do more. Those webinars, we cover new features and best practices, and also we're ramping up content on StarRocks IIO as well as StarRocks Engineering Medium account. So there was we published it's from the community, a best practice, StarRocks best practice guide, a 5-part. And we actually are looking to keep like iterating those 5-part best practice guide. And that's going to be very helpful for the users, right? And if you want anything to be covered specifically, in regards to like, you want to learn more about compaction, or you want to learn more about like ingestion best practice for like stream load or something like that, let us know, and we will definitely put them on our schedule and get working.